we'll be talking about virtualization. So before containerization, right? What it was exists. So it was basically virtualization. Okay. So before virtualization, how it was the systems, how exactly the uh, physical servers were there. That we'll talk about it. Okay. So as you could see, we will talk about. Let me pick a pencil. We'll talk about before virtualization, what is virtualization, then what is containerization, and what is the difference between virtualization versus containerization. Okay, then we will try to find it out. What is Docker and a few installation steps of a Docker bed. Okay, then we'll talk about what is image, what is Docker containers. So then we will talk about main Docker commands, what we would be using it. Okay, so then thereafter we will do a practice session. So I will explain about how exactly the application has to be built, uh, how exactly image has to be created, how exactly container has to be run. Okay, and how exactly we can access a container. Okay, so those all the bit we will try to cover it. How much it's possible we'll try to cover it. If we are unable to cover all this bit within a 1 hour time, so what we would be doing is tomorrow at the same time we'll be continuing the next step of our activities. Okay, so let us start it out. So if you know, before virtualization, say around 20 years back, what we had systems were, we had three servers. So a particular company, if a company wants to host their application, so they used to buy these servers, right? The physical servers. So we used to create one in normal MVC architecture. So minimum one web layer, app layer, and then a DB layer used to be there. Yeah, that is a standard practice. So what we used to do is we used to purchase three machines in a normal setup of this type of application. Okay, one, we used to install web layer, either Apache Nginx, or any web layers, or if it in case of a Windows, it would be IHS server, right? And what we used to have is another app layer where we used to install our JBoss or WebLogic server, or the likes of IBM servers, right? So those app servers we used to install it. Then thereafter we used to have a DB layer. So DB layer is nothing but MySQL database, DB2 database, or Oracle database, right? So to name a few, these many databases, one of a database we used to install it on our physical server. So as you could see, we used to have our own physical server, operating system we used to install. On top of that one, web layer it used to be there, right? So we used to install it. So each resource utilization was very minimal. Okay, so at that time it was a bit easy for us maintaining these servers. So it is like, this server belong, we used to put a stickers on those servers saying that this belongs to web server, this is app server, and this is DB server. Okay, we used to have Linux administrator or system administrator. Different types of roles were there. Those guys responsibility is to make sure this application, these servers are up and running. So we used to have separate data center or a server room, we used to call it. 24/7 we used to have a AC, uh, electricity, those all the things. It used to be there. It's a common bit. It used to we used to have it, right? So then thereafter what happened was, the resource utilization was very minimal. But for administrator and all those things, in this server, this is what it is running. Okay, uh, resource utilization was very minimal. So we never try to deploy some other application on this specific respective servers. Okay, so then came up a virtualization. So what is virtualization? So what virtualization, if you could see, we had a same single hardware server. Okay, in the before virtualization case, we used to buy three physical servers. Okay, so simple calculation was one server, one operating system, and one task it used to perform it. Okay, it was a simple. So next bit came up a virtualization meaning, so we had a one server. Okay, it had a host OS. On top of that one, we had a hypervisors running it. Okay, on top of this one, this on the same virtualization, it was like a on the same physical server, we had a three virtual machine. We have installed it, meaning The cost of hardware, it is same. Okay, we had a on top of that one host OS, but we used the resources of the same single server, and we deployed the three application into the single physical server. Okay, so meaning what happened was maintenance wise, right? The number of physical server was reduced for us, and as resource utilization was until the 90th percentage of a resource utilization we used to use it. With this one, cost to the company was less. Maintenance wise, it was a similar kind of a thing. Here also, Linux administrator was required or system administrator was required. The maintaining of a AC room or a 24/7 electricity, it was required, mandatory. But the cost of the capex cost, what we call in the cloud, right? So that is a little bit reduced in our case, in this case, virtualization case. Yeah. So that was the main shift it has happened. Earlier, one application we used to run either web layer, app layer, or DB layer. But now all these three things on a single physical server we started running it. Though little bit of specs difference was there, but we were able to within the same budget we were able to host the same application on a single physical server. Capex drastically it has reduced it. Okay. So now coming back to the containerization. What is containerization? So containerization is it's you package what is required for you all together, and you make sure that for your software what is dependent library, what is required. Okay, minimalism. Okay, how much it is required, that much we bundled it out. Okay, so if you could see here, this is a one container. Okay, in the web layer for Apache, or if you're going for Apache or Nginx, right? So for that, what all the binaries or libraries is required, only that bit we have bundled it and up in our image. Okay, advantage of is, so if you could see here, we don't have client OS. In the virtualization case, we had a guest OS itself, right, on each virtual machine. Okay, and it was a full blown complete operating system was installed. If you require those libraries or not, it is installed as part of a guest OS installation. In this case, what is required for this particular web layer, right? That is what we have installed it. Okay. So similarly, it has reduced that bit. So if you could see here, it is the same physical server. Okay. So resource utilization was until say approximately it became a one third. Virtualization it was until 90%. When you come back to containerization, the resource utilization was reduced heavily. Okay, it is the same workload, same type of application we are installing it. Okay, but there with the containerization, what is required, right? That is what we have installed it. So if you could have seen if any Windows operating system or a Linux operating system, if you install it, right, it takes a hell lot of space as well, right? And on top of that one, unwanted unwanted application will be installed. Okay, so you could have never used it, right? So those are all the application will be installed by default. You don't have a choice in that, right? So automatically it will be installed. In this case, what is required for our application to run, that is only binary, we add it out. Okay, so that is advantage of our containerization. It is kind of a smaller version of, okay, smaller version of our same virtual machine. Okay, you can call it as a smaller version of a mini VM kind of a thing. Okay, uh, so if you could see here, another disadvantage of virtual machine and or the before physical servers, right? So think that you have developed one very good application, okay, due to and many people started using it. Okay, so during that time, so the initial bit you had required only one web layer and the app one application itself. Due to containerization, so we have a space, right? We have a resource constraint is not there in our case due to surge in the request on your application. Many people started accessing it, so obviously you don't want your application to be slowed down or inaccessible, right, due to the load. Okay, if many people is accessing it, obviously our application performance will go down, right? So you have to scale it up. So in during that time, during the containerization, what you could do is via automation or via even via if you wanted to do it manually. Ideally we go for automation, okay, with the CPU high throughput, all those bit calculation with the HPA scaling, right? So you would be able to scale it out automatically. So if you could see here, if I wanted to increase it, I'll make it as a web equals to app equals to, and db1 is sufficient. So I can, with a small click of a button or a couple of commands, I should be able to increase the same application. Okay, so web layer I wanted to sorry, to, and app layer, with a small configuration you can scale it. Okay, so resource utilization will be little bit get increases. Okay, think that further many people are further accessing your application. You gave a one very good offer to your customers, right? And then you see surge in the traffic onto your website. So you can easily, quickly, you can increase your respective component where the load is heavy, right? So without twice thinking about the how exactly it has to be implemented, or someone has to do a deployment and all the stuff. So here there's no question of that. Okay, so if it was the same virtualization, someone has to go and build the virtual machine server, install the application. Okay, it I have seen in the olden days when the virtual machine were there, right? So any promotion people used, companies used to offer it, right? They used to build a set of a servers itself, virtual machines, and install application into that. And during the go live bit, when it is live, right, depending on the load, so they used to add some more virtual machine into that. Okay, so it is, if there is a no load, right, then automatically whatever the new virtual machine it has been built, it is a waste, right? The effort it has been put in to bring it up, installation and all those things, right? So it takes human effort. So in containerization, nothing is there. Okay, so automatically it will you can scale it up, and think that your workload is now normal. Okay, then you can decrease it in within a click of, or a couple of buttons itself. Okay, couple of configuration, we should be able to scale it down. Web 0 to this version, we can go it easily. Okay, it is in a fraction of a say probably couple of minutes. Within couple of minutes you can scale up, scale down. Okay, now coming back to difference between virtualization and containerization. So if you could see here, hardwares are same only. Okay, host OS is required for us. Okay, so instead of hypervisor, in our case, container runtime engine came into picture. Okay, so the example of container runtime engine is the Docker. Okay, Docker is the bit which does all this bit. Okay, so it is responsible for running our containers. Okay, so if you could see here, the binary libs, the smaller version, here also it is there. So if I take a same like to like example, web layer, so smaller binary libraries, whatever required for the application, it is still there. Here we don't have a guest OS. So if you could see here, yeah, the guest OS itself, it is not there for us. Okay, so that itself, it has been knocked down. And if you could see the resource utilization, right, it is minimal. It is kind of a one third. Here almost it is crossing a red bit, right, 90% of the time. So, and in order to scale it up, containerization is bit easy. Here in virtualization, someone has to go and build those bit, and build those virtual machines. So if you want an app dev, one virtual machine is unable to handle your application, you require another 10. Someone has to go and build it up. It obviously it is going to take its own sweet time, right? So your client or your project cannot afford that much of time. Obviously, during, if you say it takes whatever automation you do it, it takes 1 hour or 2 hours kind of a thing. So whoever customer came in, right, they will be lost within that 1 hour time, right? So your client or your company will be losing lots of revenue because of that itself, right? It's all time is money, right? So uh, why do we need container? Okay, so if you could if uh, if we think about in olden days, right? So why we used to have a separate system itself, or separate virtual machine itself, to in order to cater our web layer or any app layer, right? So we had dependency. So each of these application had their own, they wanted their own respective Python version, okay, or different specific version of a operating system itself, it will work, okay. So those all the dependencies were there, or your hardware should be so and so, memory should be there, okay. So those all the things, it was there. uh, for example, Python should be there in the in this specific version for web layer, app layer is different, database layer is different. In order to maintain and all those things, it was a bit difficult for us, okay. So we used to call it as a metric hell, okay. So in order to maintain that those different version in a single virtual machine itself, it was a bit difficult for us. Each time you maintain it, you go for a build and deployment of a into different environment itself, right. We used to maintain it at any cost. If there are any issues, right, some of the times in dev something works, test environment doesn't work, okay. If you see, there is a Linux patch was updated in test environment, that is the reason you are unable to see the issue in the dev environment, but you could see the same issue in the test environment. So we used to have a fighting in order to fix it. So because of that, what used to happen is end result was application is not released to the production on time, and it will make a revenue impact to the client, okay. So those all the issues were there. So this is one example, okay. So if some of you guys know about a WebLogic server, right. So this is the this is the older version of a screenshot what I have taken, this metrics matrix, okay, certification matrix. For this is for the Oracle WebLogic server 12c. If you could see here, this WebLogic software 12c version, all, when it is fronted with web server Apache or iPlanet or some other software, okay, and using WebLogic server plugin, different plugin, okay, and what type of OS bit is there, okay, and it is on a which OS server, okay, which OS server we are using it, and depending on that, Oracle used to recommend this application used to work on this kind of set of criteria only, okay. Think that you have installed on something else, okay. Then if there are any issues as well, right, the first question Oracle support guys will ask you is, have you seen our certified matrix itself? If you have seen it, and whatever your server, our server where the issue is there, if it is working on the same set of certified matrix, then only they will admit your issue request itself. If it is out of scope, right, if there is a slightly deviation, if it is there, even Oracle will say we are not supporting this type of configuration itself, okay, and they straight away close your ticket, though your issue is in a production wherever it is, okay. They used to maintain this kind of a bet. And as a customer, so we used to install depending on this matrix itself. If we deviate little bit, gone. So Oracle won't support it, whatever the version you have taken it, support contract you have, right, they won't support it. Simple. This is a certificate matrix. If you are obeying it, you will be able to do it. They will be able to support it and guide you, okay. So now as we talked about this session is on the Docker itself, right. So it's a open source DevOps tool, okay. So it is used to dockerize or containerizing an application, okay. And what we do is, in order to build our application, okay, whatever software you wanted to install it, we take that softwares, and then we create a Docker file. In that Docker file, what we do is we will mention it out what all the things in order to run this application, right, what all the softwares are required, we will mention it out, okay. And using that, using Docker, what we do is first we build the image, okay, and then if you wanted to run it on only on local laptop, you don't need to push your image to Docker Hub, okay. So think that you are running testing it on only on your local laptop. So Docker, what it helps us is to containerize, it helps you out to containerize your application. We create an image out of using Docker, we build the image, and then using docker run command, we run the application on our laptop itself. Okay, in the olden days we had a concept called always we had a fight with the developer plus ops team. Okay, so developer used to tell it will work on my laptop, it is working on my laptop, it is none of my business if it is goes to the test environment or production, if it gives a problem. Okay, it's a operation related issues. Okay, so those fight used to happen because of docker, right? So if you're working as a dockerized application, right, a developer, so if it is working fine in your laptop, same thing, it will work fine in your production environment as well. Okay, or a higher up environment. Okay, so without that, because of this, right, so there is a no fight between our developer community or DevOps community or operation community. Okay, if it works in dev, it should work in the higher environment as well, because the image is same only. Okay, so I'll just give one example. So if you could see, this is what it is. So developer builds a image, okay, using a docker file, and he creates an image. Okay, that image, once he's tested on locally on his laptop, right? So what will happen once he tested it out, he has done a testing and all those things, if he certifies that if his code is working fine, right, then only what he will do is he will create this image and push to the dev environment for the testing bit. Okay, it is the same image will be deployed to dev environment. Then once the testing has been completed by the tester or automation testing tool, what will happen is the same image is promoted to the next environment, the test environment. Okay, the same image, once it is tested from the test environment, we will move it to the production environment. The same image will be live to the production, and application is tested there as well, and customers can access the same container. Okay, but under the hood, if you could see, it is the same image. So because of that, if there is any issue over here, it will be there on his laptop as well. So now the developer cannot say that it is ops issue or some other issue. Okay, it is, if issue is there, it will be all across the environment. Okay, so the main bit of concept of our operating systems, right? So there are a couple of bits are there. So in Linux flavored operating system, so we have a hardware as well as we have a operating system. Okay, so Linux has divided, I mean, has a multiple versions of operating system. So someone has forked this bit, and they have created their own Ubuntu. They have Fedora, SUSE Linux is also there, CentOS is also there, Amazon Linux is there, Oracle Linux is there, or there are many types of Linux flavors are available. But on top of that one, it is under the hood, it is using the same kernel bit. Okay, so if you could see here, in the context of our Docker. Okay, so think that we are building our image on a Ubuntu. Okay, so if you could see here, the host OS, hardware OS is same only. On top of that one, guest OS. If we are talking about Linux versus Windows bit, right, in a Docker terms. Okay, so if you could see here, hardware server is we have a hardware and we have a Ubuntu kernel rather than SUSE OS kernel. Okay, so all these things are sorry, sorry, all these things are extended based on the Linux kernel itself. Okay, so Ubuntu is running on as a guest as a host OS. On top of that one, Docker is running. Okay, so any on top of this one, any container which is running, uh, our container is of type Ubuntu running on a Ubuntu OS, that also would be able to work on the host OS or Ubuntu OS kernel. Okay, or if you are running your containers on a Fedora OS, this will also work on the OS kernel. Okay, same with the SUSE or CentOS or Oracle Linux, Amazon Linux, whatever it is, right? So why it is? Because it is extended on the same Linux kernels. Okay, so because of that, any softwares are there, right? Hardware how exactly to differentiate it is basing mainly because so Ubuntu, the look and feel or the command, right? Whatever the Ubuntu community has developed this particular OS, right? The application, the software, what they have written, okay, the GUI in the OS, what you see it, right? Or the commands, what you interact with our kernels, Linux kernels, in order to do the work, right? So those all the things are common. Okay. So when we are using different OS itself, since it is forked or extended out of the same Linux kernel, the interaction between the hardware, it is the same thing. So because of that, so the host OS can be anything. Okay. Any flavors of Linux. Okay. But the guest OS can communicate with that one. Because of that, any Linux containers can run on any type of a host OS. Okay, in Kubernetes world, this host OS we call it as a Kubernetes nodes. Okay, as we go along, right, we will learn about a little bit of Kubernetes as well. Okay, the basics of for beginners, how much it is required. I'll make sure that also I'll try to cover it out. Okay, so these nodes, right, can be of any OS flavors. Okay, and containers can be of a different OS flavors itself. That is the reason it will work it out. Okay, but there is a one catch is there. Okay, so if it is a Windows OS, okay, or a Windows, you wanted to install a Windows workload. Okay, think that Windows container you wanted to run on a Linux uh, Linux host OS. You won't be able to do that because whatever the Windows OS interacts with the say creation of a file and all those things. This Linux kernel cannot understand at all. Okay, that is the reason only for Windows, right? So you think that you require a Kubernetes cluster. Okay, so in that case, these guest OS or the nodes, right? On this nodes, a OS type should be of a Windows OS itself. Okay, you can't do a mix and match only in this case. So major two operating system is using. I mean, our workloads are interacting with these nodes. OS types are mainly Linux type one. That's a majorly say 95% of the time Kubernetes workloads or containers run on a Linux flavored operating system itself. Okay, probably 5% of the time it is a Windows OS, but since it is a 5%, yes, you should be knowing about it. Okay, that is the whole idea about it. Okay, so the same thing I had explained it. So we have a binaries libraries. Okay, so a few of the few of the specific network configuration or mount, it will be specific to the container. Okay, the rest other part, this is our container. Okay, which has its own libraries, application, and dependencies respective to that particular component what we are installing it. Okay. Yeah, so this I had explained it. So if you wanted to do a build and deployment, we will build it on a laptop, deploy it in a dev environment, then move it to the test environment. Same thing, it is same images moved on to the further environment. Okay, so let me go to the next one. Okay, so Docker installation, it is bit easy. Okay, so probably it may take say half an hour or something like that. So I will go to the links. Okay, so if you could, 1 second, I will open new window. Okay, so if I say Docker install on I'll say Windows. Okay, major of the public will be on the Windows itself. So if you search on that, click on this. Okay, you will have a Docker desktop on your laptop. Okay, so if you install this, I have a say 3 minutes video which is available on my YouTube channel. Okay, I can share it with the WhatsApp group. It's hardly takes 3 minutes, so you should be able to install it by yourself. Okay, I will tag. I will attach the link in the WhatsApp channel. Okay, WhatsApp, all the social media channel. Okay, So if you go and install it, it will be say half an hour. It will should within 15 to 20 minutes you should be able to install it. Okay. Once it is installed, right? So as a next command, I will just go to the nitty gritty of our Docker. Okay. So let me open up a Docker desktop. So if you see here, this is our Docker desktop. Okay. So let me walk you through about how exactly Docker desktop looks like. Okay. So if you could see here under the images, you would be able to see all the images which we have downloaded it. Okay. So containers is, if you see here, my MySQL container is running on this particular laptop. Okay. So before going to this Docker desktop, let me explain about what is Docker image and what is containers. Then probably we'll come back to this GUI version. Okay. So okay, so if you could see here, 1 second, let me take a red one. Okay, so if you could see here, Docker image, okay, versus these are the two bits it applies to in Kubernetes world as well. Okay, so image, a Docker image and a Docker containers. Okay, so when we say image, right? Obviously, if you have installed few of the softwares, right, in either Windows or Windows machine or Linux bit or Mac OS, right? So in a Windows term, you can think of it as a exe. Okay, if you download any exe on your laptop, right? Uh, what it will happen? So only exe, it will be, say if it is a 500 MB application is there. Okay, you have downloaded it on your laptop. Okay, so that is what it's called as an image. Okay, as it is, image is a kind of a useless. It is using the space out of it. Okay, so space on your laptop. Okay, how exe once is downloaded, it is uses the space, right? Similarly, Docker image also. Okay, a Docker image is a kind of a exe. Docker containers, when I say Docker containers, so basically once you install your exe, download your exe, you click on the exe and install the application, right? You will do a couple of depending on the installation steps, you will select it and click on next, 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 and then once it is installed, you would, our application will be deployed on your laptop. That is a running application, right? So containers are the running application of our exe. Okay, so image is our exe. Okay, Docker containers are, once exe is installed, how exactly you will interact, right, with that particular respective application, right? That is what it's a containers. Okay, containers are always running, images are a static. Okay, it will be on your laptop itself. Okay, so when we say uh, immutable, right? So you can't modify it. Once the exe has been created or an image has been created, you can't modify it. You can create a new version of an image, okay, with the different tags and all, but you can't modify it. Okay, whereas containers, right? It's basically if you wanted to delete few of the files, okay, you can log into the container and you can delete the files, or you can modify the files as well. Okay, so image is a complete package of our application and its dependencies. Okay, whatever we want it in an Nginx application, everything we'll bundle it out and we'll deploy it. Okay, uh, whereas our containers are, it's a running instance of our image. Okay, so image can exist without the container, meaning, so exe, if it is staying there on your laptop, it will be consuming, it will be consuming your disk space. Okay, whereas I mean, you need not create a container. Okay, image, you can keep it there. Probably after tomorrow, I mean, after a couple of days, you can create a containers. Okay, but in order to run our container, right, you require your image. Without image, you can create, you cannot run a container. Okay, if there is no exe, you can't access that particular application, right? So as simple as that. So prerequisite for container is image has to be built. Okay, and it has to be there. Okay, so one image usually, I mean, if it is, if you wanted to add a few more features and all those things, it most of the time it will be created once. Okay, if there are any modification it happens, it is a next version kind of a thing. Okay, So image will be created once, but the containers can be created multiple times, meaning the same application. Think that you have a 10 team members, okay? There is a MySQL image is there, okay? Or you have developed one application, okay? Same application can be deployed in a container multiple times, okay? I can create my own website, okay? So there is a template is there, template for our if you take example of WordPress site, right? There are, it is basically WordPress site is a WordPress. If someone doesn't know about WordPress site, so most of the blogging sites are on the WordPress site. WordPress site requires uh, two applic- uh, two containers basically, okay? One is two images basically. One is a WordPress software, and second one is a MySQL, where the data it's a database. It stores all the data, okay? So think that I wanted to deploy my own WordPress site, okay? There are two images are present, okay? I can use those two images. I can create my own beginner academy website, okay? Now I wanted to create another application, another WordPress site related to finance. Finance is in a boom, right? So I wanted to deploy my own blogging site. So what I will do, I will take the same two images and create another two containers, okay, and which will host my finance website, okay. So in that manner, using the same image, we can create a multiple application, okay. That is what a difference between container and images, okay. So compute resource is not required, meaning think that resources on your laptop, right? It is how much memory is there, how much RAM is there on your laptop. If a image is there on your laptop, it won't use, it is not in a running state, okay. So that is the reason it won't consume any resources of your laptop, okay. Once you run those images as a container, right, at that time, if it is a container is running, right, it is nothing but it is using your resources of your host OS, in this case our laptop, okay. So this is the main difference between image and container, okay. So I will go to the Docker hub, okay. Docker desktop. So as you could see, this is my Docker desktop, okay, what it is currently running it, okay. So if you could see here, there is a front end, yeah, it was exited. So let me delete it. Let me delete it later. Yeah, so if you could see my MySQL, so if I click on images, okay, so if you see these many images are, I have downloaded it on my laptop, okay. So one among is our this MySQL image, okay. 26 days ago I have downloaded it, okay. So this image is running it. So this is not consuming any resources, okay. It is consuming only the disk space. In my case, 592 MB it is consuming it, okay. So this MySQL image, okay. So if you could click on this, okay. So this particular MySQL image is of 8.0 version, okay. So if you could see here, there are two images are it is using it. One is Oracle Linux, that's a OS type, okay, and the MySQL 8.0. This is the two image which has been built on a MySQL. We are using it. So that is meaning MySQL 8 is running on a Oracle Linux, okay, operating system. Our MySQL operating system is Oracle Linux. Our MySQL has been installed on this particular image, okay. This is our image, MySQL image, okay. If I click on containers, you would be able to see this is our container, okay. MySQL.80, this is running, its state is status. If you see, it's running, okay. Running on this particular port 3306, that is a default port of a MySQL, okay. So if you wanted to see how exactly it looks like, right, so you can log into this particular containers itself. How? So click here, just say open in a terminal. So if you could see here, I have opened in a terminal. So if I say who am I, I'm a root, okay. So now I wanted to log into MySQL. This is basically a few commands, okay. So let me, okay, I have not logged in. 1 second. Let me see the password what I had given. I've forgotten it. Yeah, this is the password. Okay, so let me go back to my terminal. Okay, now I have logged in. Okay, now logged into MySQL. So this is on a container, Docker container running on my laptop. Okay, so think that as a beginner, you wanted to practice any SQL commands or any software you wanted to test it out. Okay, you don't require any virtual machine running on a cloud and all, or a dedicated system and all. You, whatever the most of the softwares, all this application, you will run it as a Docker container. Okay. For example, if you wanted to run this MySQL database, you wanted to practice few of the tables, few of the SQL commands. Okay. Let us see. If you wanted to see all the tables present in all the database present in this particular MySQL, just say show databases, you would be able to see. So if you wanted to create a database, okay, say create a database, we'll say test. Okay. So if you see, has been created. If I do again show database, the test it has been created. Okay, earlier it wasn't there. 4 rows were there. Now it's a 5 rows. Okay, in this way you can practice any softwares. Okay, which images publicly available. How you can see the which how you can see which images are available. For that, what you could do is let me go back. Okay, so we have called as a Docker Hub. Okay, if you see here, if you go to Docker Hub, so this is a container registry. So we call it as a container registry, meaning all these companies are there, right? What they do is, if it is a free version and all, so these guys, these companies, they will build a Docker image for you and upload it to here. Okay, this is a free account for and if you're a beginner, you wanted to try it out, just deploy any of the application, just create a one, sign up, it is a free. Okay, just log in there and you can practice it. Okay, so if you see, I have used MySQL. So if I see here, this is the MySQL official images of MySQL. If I go here, this is the version what I had used was 8.0. Okay, so here if you see, there are different versions of my different tags. Okay, that's meaning versions of MySQL is available. Whichever you want, you can use that. So if you see here, if I see Docker 8.0, okay, so this is what I'm using it. Okay, and here it denotes that it is a official image of Oracle. This particular image. Okay, this MySQL version is built by the official guys of these companies. Okay, so think that you wanted to search it out. Okay, so if you click on there, Docker Hub. Okay, so let us say MySQL. Okay, so if you could see, you will get these many links. You are interested only in the official images. Okay, so click on Docker images. Okay, whichever you wanted to test it out, put it over here. You should be able to find it out all this bit. So let us say you wanted to search Elasticsearch or Kibana. Okay, so this also you should be able to find it out here. Okay, so I also developed a few of the softwares, few of the images. These are all basic. Beginner Academy. If you go here, okay, this is our images. Okay, beginner academy. If you go to the tags, these many versions I have created. Okay, you can use it or you can build your own bit. Okay, uh, how exactly you can do this bit, that is what we will be learning in the next starting from now. Okay, so the basic commands what we use is, so if you could see here, Docker pull. Okay, what is the use of Docker pull? Okay, so Docker pull is, there is an image available over the Docker Hub, over the internet, in the Docker Hub container registry. We call Docker Hub is basically nothing but all your images. If you wanted to keep it and you wanted to give it to the public, right? so that you can keep it in a Docker Hub, and it is accessible over the internet. So anyone, one of you wants to pick up this bit, you can just copy this bit. You can access it. It's a public image. Okay, you can access this, and first Docker has to be installed on your laptop. Then only you should be able to run all those bit. Okay, so let us run the first command. Okay, that is basically our pull. Okay, so first command, let me check it out. I have that particular image or not. Okay, so if you see Docker image list, I don't have it, I know it. So if you see, I have only these many images present. How you can see that? Another way is, you can click on here images, you could be able to see your images present, okay, which has downloaded on your laptop. Okay, so in the from the command line is Docker image list. If you see that, you can I have only these many 5 images on my laptop. So now the first command is Docker pull. Okay, so if you see here, I wanted to pull my beginner academy BA Nginx of 1.9 tag. Okay, download into my laptop. Okay, Docker pull is used to download an image which is available over the internet in a container registry. Container registry can be Docker Hub. For simplicity's sake, we will use Docker Hub itself. Okay, we'll come back to Azure Container Registry as we go along. Okay, but as of now, container registry. So from a Docker Hub, we wanted to, there is some images there, you wanted to download it out. Okay, so for that bit, what you do is just say Docker pull command. Okay, so if you see here, what it does is Docker pull command, when I run it, it starts to download my image which is available over the internet. Okay, so if you could see, these are all the 5 are there. So let it download. So couple of minutes it may take. It should be able to download. So let us wait. Yeah, once it is downloaded, right, we can see our image on our laptop. Okay, so if you see, downloaded our Docker image. Okay, so this is what we have downloaded it. So if I do Docker image list, right, you should be able to see our beginner academy 1.9. Okay, this is what we have downloaded it. Okay, that is the first command. So if you see here, these are the main top commands we use in Docker bed. Okay, so Docker pull is the first command. Okay, the next command is Docker run. Okay, so if you see here, our image, right? So our image is installed. Okay, so which is available over, if you could see here, this one, right? So you wanted to run this image on your laptop. Okay, so what I will do here is I will run a command. I'll say Docker container. Okay, Docker container name I am giving it. I will say Azure bootcamp. I'll say bootcamp. Okay, the name I am giving it. D stand for detached mode. IT stand for interactive mode. Okay, minus IP stand for a port. Okay, so port is 8080 is my port. From my laptop, I'll be accessing this application. Okay, 80 is the container port. Inside of our container, our Nginx server will be running on port number 80. Okay, and this is our image name, we are mentioning it out. So in this case, we have downloaded 1.9. So let us use 1.9 itself. Okay, so let me run this out. So if you see, my container is running. Okay, so I will go to here. I'll click on containers. You should be able to see. Okay, why did it exited? Oh man, so there is some issue with the 1.9. So let me go back to the some other image. Okay, let me, it is giving some error, so I was trying it out, looks like. So let me delete it off. I could have tested that. It's okay. So let me delete the image as well. Let me use the older version, okay, where I know which is working fine. Say, let us say docker pull 1.4. Okay, so let it download. Okay, so a new image should be downloaded. Okay, if you see here, our 1.4 is also downloaded, 1.9 is also there, two versions. Okay, two different versions. So let me run it again. 1.4. Okay, okay, so if you could see here our boot camp. Okay, if you see here images, our BA Nginx 1.4, it has been, image has been installed. Okay, now what we run was a Docker container run. Okay, so this is our container we are running. Okay, so if you wanted to access it, if you remember, I have told my command that it should run on a 8080 port. Okay, so if you click on here, it will open our application. So if you see here, this is our application. Okay, welcome to demo session 30th April, something it has been mentioned. Okay, this is what our application is running inside our container. Okay, so if you could see here, if you wanted to log into this particular container, okay, so I'll say open in a terminal. Okay, I'll say bash. So where exactly our data is there? Okay, so if you could go back to this particular location, so if you see, this is what it has been printed, right? So I wanted to change it to the current one. The HTML file, okay, when I say it's you can go and modify your container, right? So we will be modifying the actual content. Okay, so if you see here, uh, there is a index.html is present. Okay, so I wanted to add that one. Okay, so if you see, this is what the same content what it has been displayed in here, right? That is what we could see here. Okay, so now I wanted to modify this bit, index.html. I will say vi. Okay, if you see here, vi command not found. As I said earlier, our containers are what is dependency minimum it is required, right? That is what we have kept it inside this. Even the vi command, which is a basic editor, which is not shipped within this particular image. Okay, in order to save what is required, right? That is what it is there. It is a concept of minimalism. Okay, so now how exactly we can change it? So I will say echo. Okay, I'll mention what is today's date, 13th May, right? 13th May, Azure DevOps session. Okay, I'll say this, and I will say push it to our index.html. I'm modifying our index.html here. Okay, content of our index.html. So if I do cat again, you would be seeing 13th May Azure DevOps session. Okay, if I go and refresh this, you would be able to see my application, whatever I've changed it, right? It is reflected over here. Okay, as you could see, it is modified, right? So think that you wanted to make further changes on your container, right? So any application you wanted to do it. So I will make it as Azure DevOps. Okay, so I will say 13th. This is Docker session. Okay, I'll push that bit, and I will, if I modify the index.html now, if I do a refresh, you should be able to see the whatever change we have done it. Okay, but this is, we are directly modified on a container. Okay, it is not available on the image itself. Okay, so think that I wanted to run this version as well as the older version as well. Okay, using the same container run command. Okay, this is what we call it as a same image we can run it in a multiple times, multiple different way. I will say Docker bootcamp, it is a 1.4 version, right? I will name it as a 1.4 version. Okay, so only bit changes I need to do is I need to change this port, because already one Docker container is running on a 8080, right? That is the previous one. So I wanted to run on 8081. So if you see, it is running on that. So I will go here, check here, it has been appended, right? So I wanted to go and test it out. So let me go and here, okay, I will go back here. I will say 8081. If you see, this content is of our original, whatever we have modified here in this container, in this new container doesn't have the new modification, meaning I can run different application using different applications, different types of version we can run on containers, using containers. Okay, so same image we can run as a container, and once it is running at a runtime we can go and modify it, okay, and still it can be running. But if due to some reason that container gets lost, right, then it's gone. You will be losing the content whatever we have been developed. Rather than that one, we need to build an image of our new version and push it to Docker Hub and reuse that. That we will be trying it out now. Okay. Uh, the next command is to see the processes, okay, of our Docker. What is how many processes are running? So what we will do, we'll say Docker ps minus a. So if you see here, whatever it has been exited, right, that also it will show you. Okay, Docker ps minus a. Ps stand for our processes. Okay, minus a stands for all. Okay, so if I remove only ps. Okay. Okay, so only if you remove ps, right, so it will show you only the running containers. When I say minus a, right, it will show all the bit, all the containers. Okay, so in this case we are running only 3 containers. One is a beginner academy 1.4 with the name bootcamp 1.4, and one other one is a bootcamp. Okay, and another one is a mysql 8.0.